Hey kids, Mr. Krause here, MrKrauseMath.com. Hey, by the way, I have over 100 subscribers now, so if you've subscribed to my channel, by the way, it's like 7 o'clock at night. I've been going since 4:30 this morning. Haven't had a nap yet. I'm going to be a little tongue-tied. Could make some mistakes. Call me out on them. I'll try to make some bubbles in the sky in the video. Maybe I'll call you out, give you some props for finding my mistakes. But if you'd like to subscribe to my channel, go ahead. I'm having over 100 subscribers. I want to be like huge. Like I'll be as huge as the hugest guy on YouTube. And maybe I'll get a sponsor from Brugger's because, you know, I like to drink my Brugger's coffee. Hey, this is the only way I'm staying awake, so you got to deal with it. All right, here we go. So, let me lay out the premise of what's going on here. Got a triangle. You need to find the area of it. No problem. I learned that in 5th grade. Maybe 4th, maybe 3rd. I don't know. Way down there in the elementary building. So, you say to yourself, that's easy to do. That's not a problem at all. I can do that. It's area equals 1. I don't know what's going on with my pen. That's just ridiculous. 1/2 base times height. No problem. That's weird. Problem. Don't have a base. Well, that's easy. This is just a Pythagorean triple. That's 3 squared. That's 5 squared. This has to be 4. Wow. This is a multiple of 3, a multiple of 5. This has to be a multiple of 4. So that's a 3, 4, 5 right triangle in the form of a 6, 8, 10 triangle. Because 36 plus 64 is 100. So I know the base is 8. I know the height is 6. To do this would be rather elementary, but not 3rd and 4th grade. You know, Pythagorean theorem, Pythagorean triples. Got to be a little bit older than that. Maybe 7th, 8th grade. I'm not sure when they teach that anymore. 8 times 6 is 48. Half of that is 24. No problem. Got it. Ooh, Mr. Krause. Math's easy. Then I gave you this equilateral triangle here. And you know what? I probably should have shown you that I drew in a altitude. Because if I don't put those right angles in, you can't really assume they are. Because that makes a, well, you know, out of you know and me. And I don't want to be a you know what I mean? So, there's a 2. I can tell this is 1 and 1 because when you draw in an altitude in an equilateral triangle, it divides it, it bisects it. You learn that in trig, or you learn that in geometry. And then I'm not going to go through this long drawn out process to find out this is the square root of 3. By now, you should know that. So, the base is 2. The height's the square root of 3. I do the area equals 1/2 the base times the height, which is equal to 1/2 times 2 times radical 3. That's just radical 3. Basic stuff. So why is this in an algebra 2 trig area? Well, now what? Not a right triangle, even though that kind of looks sort of like, not really like a right triangle. I don't know if that's a right angle. That's not a right angle. You cannot use 1/2 base times height without a right triangle. And yes, you could try to draw these in. It doesn't work. So there is a formula that we will use. It is on your formula sheet. So if you bounce over to the formula sheet, there it is, right there. K equals 1/2 AB sine C. But Mr. Krause, why would they use a K and not an A? Well, it's because oftentimes A is used for a vertice, and then we get kind of confusing. Especially since this is just one form of this. I can use K equals 1/2 BC sine A. And you could sense, oh, I get the confusion if you had A over here, A equals 1/2 BC sine A. What's A? What am I, you know, does A stand for area? So we use K. It's a constant. Usually K is used for constant. This isn't really a constant. I'm not really sure. Maybe a little bit extra credit for those who can figure out what the heck, why they use K. I haven't looked it up. Don't really care that much. I use the formula. 1/2, how about AC sine B? You can use this formula for any triangle at all. And at some point in your career, you'll probably prove this. For as far as algebra 2 and trig goes, we're just going to utilize this great equation and see how it works. So I'll come over to my drawing, and what it says is if you are given, and we'll go back to the original, if you are given a side A and another side B and the included angle, it's the included angle. Can't be just any angle. It has to be the angle in between those. They call that the included angle. Then you are able to use that formula. So let's see how it comes to look. Find area to the nearest integer given this information. Well, you probably should draw a nice quick triangle. You should do a relatively decent job of labeling, and I have no idea why I started out with B. Kind of weird. A, B, C, whatever. B is 150. Now, does it matter that that actually doesn't look anything remotely like a 150-degree angle? No, it doesn't. I'm still going to use this formula, but only if I'm given the side lengths. Now, labeling vertices is not a problem. Now, last year in geometry, you should have learned that opposite capital A or vertice A, you should have little a. Opposite capital C or vertice C, you should have little c or lowercase c, and then little c. That's really good math terminology. I'm sure my English teachers are not happy with me right now. I don't care. A is 24. Bam. Oh, as long as I have C. Oh, look, I have C. Oh, amazing. I have C as 17. So I have two sides and the included angle. So I can use the formula K equals. Now, it's not going to be 1/2 AB because I'm given A and C. So it's 1/2 A. Oh, I probably should be doing lowercase. AC sine of B. All right, not a problem. 1/2 24 times 17 times the sine of 150 degrees. Now, I would argue, my students, probably anybody that's really serious about trig, should know that the sine of 150 is 1/2. And then that 1/2 and this 1/2 make 1/4. And that 1/4 times 24 makes 6. And then 6 times 17 is, well, 6 times 20 is 120. And then we'll subtract off 6 times 3, which is 18. So I'm looking like maybe 102. I'm guessing 102. Those of you that are sitting there going, huh? Dude, seriously? Seriously. What's going on, man? What did you just say? Because all I heard was 102. So, for those of you that are not technologically, you are fraction phobic. By the way, 0.5 is the same as 1/2. For those of you that are fraction phobic, or just can't stand them, we'll do it this way. Times the sine. I hope I'm right, because I'm gonna look kind of stupid if I'm not right. I think I am, but I'm not really sure. Bam! Woo! There it is, 102. All right, don't stop listening. I just do all this crazy antics to try to entertain. I could be speaking like this in a boring monotone voice talking about mathematics. Let's go to the next problem. There we go. Remember that problem I had before? I don't know if you've watched too many of my videos. I couldn't get my computer to go up. Oh, there it goes. We got it. All right. So that's a relatively simple problem. Just an easy way to find the area. Here's another example of how you can use that same formula. I think I spit on my graphics tablet. Little burpage. Sorry, kids. What happened? Come on, give me my pen back. There it is. Going to draw my triangle. A, B, C. Little b, little c, lowercase a. And I'm looking here and I say, oh, wait a second. What's going on here? They're giving me the area. They're telling me I have the area, which means, okay, I really have the area is equal to 60. Now, why am I writing A? I probably shouldn't be writing A, should I? Probably, if I'm going to use this formula, and I don't want to get confused with that vertice, I probably should be using, that's right, you guessed it, K. And K equals 60. So if I come over here and I use the formula, K equals, let's see, 1/2. Now let's see, we are given B. So I know at the end of this, it's going to be sine of B. And A is 25. And we're looking for C right here. So it's going to be the AC. 1/2 AC sine B. So K, hold on a second. I'm going to try to make that into a 60. K is 60 is equal to 1/2 times A, which is 25, times C, which is C, times the sine of, oh, I didn't put in the 30 degrees. 30 degrees. Sine of 30 degrees. So let's see. This is 60 equals. Now, take a look. See what we got here. We got numbers here. And it's all multiplication. And since multiplication is commutative, that says, in very layman's term, I can multiply in any order I want. So I'm going to multiply those two together and those two together. Well, once again, I have sine of 30. I'm not going over to the calculator. Sine of 30 is a half. And this other half make 1/4. And 1/4 of 25 is 6 1/4. You don't believe me? I'm going to show you anyway. Divide by 6.25. Divide by 6.25. Ka-cham, ka-jam. Let's see how close I can get. Well, 60 divided by 6 would be 10, so it's less than 10. How about 9.5, 9.6? Let's check first to see if my math is correct. 1/4, 0.25 times 25. That should be 6.25. And then 60 divided by 6.25 is... Somebody got it right. 9.6. I did the problem the other day. That's how I knew the answer. I'm not that smart. But I fooled you. Oh, another way we can use the area of the triangle formula. Notice here what's going on. They're giving us the area, so they're telling us that the area is 45. They're telling us two sides. And this gets, they said find two possible values for the measure of the included angle. You're going to see how that plays at the end of this. So what we'll do is I'll draw a triangle. And it doesn't tell me how I'm going to label it, so I'm just going to label it A, B, and C. A, B, and C. And we're going to go looking for this angle. So we were given 18, and we were given 10, and we also giving that K equals 45. Okay. So I'll set up my formula. K equals 1/2 A, B sine C. I use C because that's the actual formula, so I might as well go use C when I can. So 1/2 10 times 18 times sine of C. Well, let's see. Half of 18 is 9. 9 times 10 is 90. And they did tell us that the area was 45. So 45 is equal to 90 times sine of C. I still need to solve for sine of C, so I'll divide by 90 and divide by 90. And hopefully you guys are all smart enough to realize that's just 1/2. 45 divided by 90 is 1/2. And at this point of your life, you should know that theta has to equal 30 degrees. But wait, didn't my problem say 2? What were they talking about? Oh yeah. Sine is positive in the first quadrant, 30 degrees. Or it could be in the second quadrant of 30 degrees. So not only could it be 30, it also could be 150. The 150 comes from working in the second quadrant. This is a reference angle of 30 degrees. You should know about reference angles. And what I do to find any angle for sine in this quadrant is take 180 degrees and I'll subtract off whatever that angle is. In this case, it's 30. So those are my two answers. Let me work on, I'm going to do maybe 2 more. And then I'll let you guys finish the rest of these. I'm going to do 2 more. I'm going to do this one 7. Find the exact area of this triangle. So let me draw my triangle. Ka-cham. A, B, C, little a, little c, little b. We were given that angle A is 30. Isn't that nice? Little b is 12. Little c is 16. So k equals 1/2. Ah! You know what? I changed this problem. I don't know why it's still... I know I changed this problem. I'm going to change this problem, and you'll see why in a minute. I'm going to change the degree measures here. I'm going to change it to 60 degrees. So instead of using 30, I'm going to use 60. You'll see why in just a second why. Because this problem otherwise is really quite boring. 12 times... I know what you were just thinking. It's math, dude. It's all boring. Well, that's a very negative attitude. Gosh. I live for math. I do math 24/7 just about. I love math. So I typed this into my calculator. Now, had I left this as sine 30, we've already discussed this a couple of times, the sine of 30 is 1/2. So literally, I could type this into my calculator and bam, it would pop up the right answer. And that really isn't testing whether or not you're looking for the exact area. So I'm going to use sine of 60 because that's one that we as math teachers expect you to have memorized. The sine of 60, well, since the sine of 30 is 1/2, by now you should know that the sine of 60 is the square root of 3/2. So let's see what I have here. Let me teach you a little bit of cool math because and this is how math teachers make themselves look smart. We got tricks galore. Like right now, I'll tell you that's 48 square root of 3, and you're probably going, huh? What? Let me teach my tricks. Stay with me. You're going to learn all kinds of cool stuff. This 2, remember this is really 12/1, and this is 16/1. Ooh, wait a second, looking a little easier. 2 goes into 12 6 times. 2 goes into 8. 2 goes into 16 8 times. And what I have left over is 48 and radical 3, and then a whole bunch of 1s. I don't need them. So k equals 48 radical 3. All right. Last problem. Question 10. The two sides of a parallelogram. Whoa! Whoa, 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 whoa! I have an area of a triangle formula. Herr Krause vom Nachbarhause. Wenn ich Deutsch reden mit meinen Studenten, sie haben keine Ahnung, was ich sage. Es ist so verrückt. Ich kann die ganze Klasse in einer anderen Sprache sprechen und sie denkt, was ist los mit dieser blöden Kuh? Hat er einen Kopfweh? Hat er ein Problem? Was ist los? You guys like my German? That's just enough to get me into trouble. All right, here we go. It's a parallelogram. So what? Draw a parallelogram. Once you draw it, you might see something. You might see something. Stare at it for a couple of seconds. We know this is 2. We know this is 5. It says that the angle in between the two sides is 49 degrees, 28 minutes. Who thought of that stuff? Right? Right? Seriously. But if you stared at it long enough by now, you should realize, oh, wait a second. Isn't a parallelogram just made up of 2 congruent triangles? And I always tell my kids, you can use k equals 1/2 AB sine C. Again, don't forget C is the angle that's included in between them. Or, since I'm going to double it later anyway, let's just get rid of the half. I don't need it. Makes life easy. So this is actually the formula now of a parallelogram. We don't need the 1/2. So k equals, someone's watching right now go, yeah, well, try doing that one in your head there, brah. Don't call me brah. That's ridiculous. It's kind of embarrassing too. That one will not be done in the old head. I know it's 10 times something. 49/28. So 10 times the sine. And to get that, I'm going to go in here. Ding, ding. 49/28, right? 49/28. And I hit enter. 7.6002. 7.6002. Round to the nearest tens place. We're at 7.6. So really, that's all there is to that. There's nothing more to that. Download this assignment. Finish it up. That's the rest of the homework. Hopefully you understand a little bit about that simple formula on the formula sheet. You'll find it in the top left corner of the formula sheet. There it is. K equals 1/2 AB sine C. And that can be used for any triangle. Let me just prove that to you. Go back up here. Check this out. We said the area of this formula area is 24, right? Watch this. Let's use the formula. K equals 1/2 6 times 8 times the sine of, wait a second, isn't this 90 degrees? Oh yeah, sine of 90. And someone's in there going, well, isn't the sine of 90 just 1? Oh yeah, sine of 90 is just 1, so I don't need that. And then 1/2, 6 times 8 is 24. And therein is the end of my lesson. Thanks, guys. Peace out. Talk to you later. Have a good night. Have fun storming the castle. By the way, if you haven't seen Princess Bride, please watch it. It's a crazy movie. Awesome. Bye.